Hi, today we are looking at section 5.9, which deals with local linear approximation. For this, we're going to say that our function f has to be differentiable at a location of x equals a. And given the function takes the form y equals f of x, the equation of a tangent line to y equals f of x at x equals a is y minus f of a equals equals f prime of a times x minus a, or rearranging that y equals f prime of a times x minus a plus f of a. Now, for linear approximation at x equals a, the approximate value of f at that x value is equal to f of a plus f prime of a times x minus a for values of x near a. So we'll show how this works. So, for example, use local linear approximation to estimate the value of the square root of 35. So what we're going to do is say, let f of x equal the square root of x. Now we're going to look at a value we do know of square root. So we don't know the exact value of the square root of 35, but we do know the exact value of the square root of 36. So we're going to say f of 36 is equal to square root of 36, which is 6. Now this also gives us a coordinate point. It gives us the point 36, comma 6. Now, if we take f prime of x, we know the derivative of the square root of x is 1 over 2 root x. So we'll look at what our value of this is when our x value is 36. So we've got f prime of 36 is equal to 1 over 2 times the square root of 36. So that gives us 1 over 12. We'll then utilize this in the formula fx is approximately equal to f of a plus f prime of a times x minus a. So we know f of x, which in this case is 35, is approximately equal to our f of a, which was 6, plus f prime of a, which was 1 over 12, times our x value, which was 35, minus the a value we used, which was 36. So we can say that this is approximately equal to 6 plus 1 over 12 times negative 1. So we can say the square root of 35 is approximately equal to 5.92. Next example, given the function f of x is equal to x cubed minus 1 over x plus 2, use local linear approximation to estimate 1.12. So I'll start by rewriting this equation. So we've got f of x equals x cubed minus 1 over x plus 2. Now in this case, the a value that we'd probably use would be 1. So we've got f of 1 is equal to 1 cubed minus 1 over 1 plus 2. That'd be 1 minus 1 plus 2 gives us 2. So we know f of 1 is 2. Now we'll take the derivative. So we've got f prime of x is equal to 3x squared plus 1 over x squared. And then we'll put our or our a value of 1 in. So we've got f prime of 1 is equal to 3 times 1 squared plus 1 over 1 squared. And that gives us 4 in this case. So we've got f of x is approximately equal to f of a cross f prime of a times x minus a. So our x value was 1.12. That's approximately equal to our f of a, which was 2, plus our f prime of a, which was 4, times our x value of 1.12 minus a value we used, which was 1. And that gives us f of 1.12 is approximately equal to 2.48.